Welcome, Prem. Uh, this is the Next Generation Technologies event uh, organized by the Ministry of Education, Pandit Madan Mohan Malviya National Mission on Teachers and Teaching, and led by Ramanujan College, Delhi University, along with the Emerging Open Technology Foundation, as well Frost, the free open source software foundation, Frost we call it. So what we have here to the audience, which is all faculty, this is a part of faculty development program. So all the universities, research associates and various faculty and students are there, mainly faculty. So let me introduce you to uh, Prem Shankar. He is a leading technology strategist and speaker at various startups and advisory coach and author of Intel software. Is author too for various blueprints and other things. He is from Pondicherry and he's currently in the Bay Area and then moved to East Coast to develop the 5G for the 5G and 6G uh, uh, towards the technology deployment. And he's an Intel software innovator, and he has been driving products for 5G enterprise, CBRS, ORAN, and network slicing, etc. Around 2 decades of software product engineering includes product architecture, delivery of multi-cloud, SaaS, and networking domain. Currently VP engineering at Cohere, leading a team of high-tech staff, building layer 2, layer 3 radio software to work with RIC, Radio Intelligent Controller, 5G ORAN. He has worked in similar areas in the past with Lumina Networks as product manager. He's well known for his community leadership in Akraino to ODL. As part of Ericsson engagement, he has developed great insight into building open source software and telco clouds. Welcome to uh, Prem, and it's your floor. Take over.
Thank you, Prakash. Good to meet you all. So, as Prakash mentioned, I've been part of the whole 5G ecosystem since 5G started. Back at Ericsson, I was part of the open source as well as the SDN controller, and also I continued to build the know-how around cloud native, particularly uh, cloud native models for telco. And most recently, I've also got into the ORAN, particularly focus on building XApps in the RAN intelligent controller, which plays a very important role in the disaggregated 5G architecture, right? So as part of my session today, I'm going to give a quick overview about one key component, which is the orchestration, right? The reason being, to put it in simple terms, 5G is all about RAN, transport, and then the cloud, right? And when we talk about new models, particularly new workloads, which is essentially the ultra reliable low latency or the massive IoT or the EMBB, in order to realize the models, the whole infrastructure has to be more composable, right? You would need to get the requirements from that of the business, and then you should be able to build the network or build the infrastructure on the fly, right? So what is going to be important is the intelligence that lies in the orchestration, which can essentially understand what is the business needs or the intent, and then it can create the infrastructure based on the requirements, right? So that's where I'm going to talk about. So the rest of the session, I'm going to talk about a super blueprint 5G. Also talk about a bit about ONAP, which is open source orchestration, which is well adopted by few of the telco giants. And then also touch upon edge orchestration, which is again an important component because particularly to realize some of the models like URLLC, you do need to have network functions as well as the applications hosted near the edge. And I will summarize putting all of it together on how to realize a true 5G cloud native based network architecture. Okay. So in this slide gives a complete ecosystem. On to your left, you see user edge. That's where you have the UE, which is the user equipment. You have, we call it as a smart edge because the edge has to be um, smart enough, be it from the intelligence to that of the data collection to that of providing or connectivity solution to varied devices. As you see, it's not just the mobile phone. It's about say AR, VR. It's about automated car. It's about smart devices that has to be brought into the network. So from that aspect, the user edge is a very very important component, right? And if you look at this particular user edge, you do have some of this open source technologies, particularly the edge virtualization. Then you also have Fledge, as well as Zephyr, which talks about constrained device edge. They create the ecosystem. And then the next one is essentially the service provider edge, right? This is what I have been primarily focusing on. um, Particularly, I've been the PTL for one of the project called Private 5G LTE, which is under the Akraino project. And what we do here is we tend to create um, all of this core, particularly 5G core, based on cloud native technologies. And then we do have an orchestrator, which can essentially orchestrate the network functions, and then they can host it on edge, or depending upon the type of I would say the workloads that particular infrastructure need to support, right? So the edge stack is primarily, you can say, openness, which is again open source project from Intel, and then the Akraino, which is essentially a aggregator of many of the blueprints, and one of the blueprint is about private 5G and LTE. And moving on to that of the cloud and core, another important component is the Magma. I believe many of you would be familiar with the Facebook connectivity solution called Magma. And in fact, Akraino blueprint, whatever I was talking about, we collaborate with Magma. And from a cloud infrastructure perspective, I think this is quite self-explanatory. Onto the cloud infrastructure, you have some of the components, which is essentially about the data plane, acceleration, and again containerization. And then from a, again touching upon the management orchestration, the global orchestration is primarily played by that of the ONAP. And of course, the infrastructure or the resource orchestration is played out by multiple stacks, including Kubernetes and OpenStack. I believe most of you are familiar with this platform. And then from a networking perspective, it's SDN controller as well as the Tungsten Fabric, which essentially does the network orchestration. But to put it in simple terms, that's the super blueprint 5G, right? Now let me dive deep into what we do in the private 5G LT, which is again with orchestration as a focus. This is a typical private LT or enterprise deployment, right? You have network core, and particularly in the US, you do have the CBRS band, which is essentially accelerating the adoption of private 5G, because it provides you the ability to request for a spectrum. And this particular spectrum is primarily provided by what we call as a SaaS provider, Google, Nokia, Parallel Wireless, or some of the SaaS provider, wherein you pay them like few cents, and then you would get the you will essentially get the spectrum based on your latitude, longitude. So we leverage that. And when we talk about a typical enterprise, you do have multi-site environment, right? Because what happens is a typical enterprise, when we talk about having to have different workloads, you would have different edges. That is where you're seeing it as a network edge, and that's where the UE lands, right? Now, the building blocks for this is, of course, the Kubernetes, because we're talking about cloud native, and then the SD-WAN in order to ensure you have connectivity with respect to that of the different network edges. And onto the core, you can have a EPC for the LTE, 5G core for the 5G. That's pretty much hosted on the core, but When we talk about extending some of these network functions, particularly we call it as the app placement, then you do need to have UPF, sometimes UPF, SMF, as well as the AMF. They are all hosted at the edge in order to service certain applications that are latency sensitive, particularly URLCC type of applications, right? That is where on the network edge, this stack would essentially contain Kubernetes, again, openness for the edge orchestration. Then you have the CBRS that I was explaining. You have the UPF. Then the edge apps is what is going to be mostly hosted on the edge, and then the SD-WAN in order to have connectivity to that of the core, right? So this is in a nutshell on how typical enterprise 5G or an LTE network would look like based on our stack. This is again the blueprint overview. Mm, This is just expanding what are the other components. This is a different view, but to put it in the orchestration perspective, you see the ONAP component that essentially would help you to host the elements, the different elements at the core as well as the edge. Moving on to the next slide. The next slide would essentially talk about the ICN stack. This is, if you look at it, the hardware and the host operating system, they're well known, but you do have a bare metal provisioning via a combination of Metal 3 BPA controller as well as KUD, right? That's essentially for bringing up any of the components right from the bare metal. And there is another blueprint which we leverage because that's the infrastructure blueprint. We call it as the integrated cloud native stack. This is again primarily driven by Intel, and they provide us all the needed components. And then the orange components, which is essentially the LT 5G RAN, the VEPC as well as the 5G, then the application function integration as well as the UPS. Those are the components that we primarily focus on, and that is being brought as part of the orchestration, right? So that's a simple nutshell. Moving on, we looked at ONAP as a global orchestrator. You saw that it needs to work on a multi-site environment, but it's also critical that you need to look at the local orchestration, wherein it can be an application orchestration, right? What is meant by application orchestration is cloud native is all about not just defining a microservice architecture. It is also about, depending upon the environment, you are indeed looking to compose your applications based on the requirement, right? So that is where in this diagram you see microservices being distributed across. So in this case, we piggyback on the ENCO. There is again, this is part of the openness, which essentially helps us to drive the geo-distributed edge applications, wherein you define the recipe on what you want, and depending upon the driving factors, which is essentially the constraints, rather to say, it can be about latency, it can be about bandwidth, it can be about proximity or affinity, it can be about privacy, right? So these are being defined as recipes, and depending upon the recipe, the orchestrator instantiates the applications along with the network function at the edge side in order to meet the use cases requirement, right? When I say use case requirement, it can be a use case of an AR, VR, right? Or it can be like a remote debug, or in this example, you see a smart city application, right? So now, depending upon what is that you want, the orchestration takes in this input and then instantiates those components that are needed onto the edge sites, and then brings up all of these components end to end, right? So that's in a summary about what we do as part of this particular Acrino blueprint, as well as how orchestration plays a very important role in 5G. So these are some of the references which you can use as part of your research if need be. And if you have any questions, you can always reach out to me. Yeah, so that's what I wanted to talk about in a nutshell. Okay.
Yeah. So one question you can answer
I think,
for us.
did you record? Okay, is it
Yeah,
record? Okay.
everything is recorded. Yeah. So what I wanted to say at this time, Prem, just before you leave, one or two questions. One, how do we reach you, and what area you can guide people specifically related to uh, the 5G and 6G areas which you are expert.
Sure. So, in fact, one area you can reach out to me is around the network functions, cloud native network functions. Um, I can, in fact, send across to you some of the earlier talks that I've been giving around this particular area. I've done a lot of workshops along with
Okay,
Intel.
that will
Um,
be fantastic because I can add to the references. You go ahead and send me those links, and I'll
and
add it.
then I can be I'm reachable via my Gmail, premsankar, PREMSANKR @gmail.com. I'll again share it with you, Prakash. You can
Yeah, go ahead.
send it to.
What I'll do is I'll put it in the Q&A, your link in
Mhm.
the slide so that people can use it.
Sure,
And
definitely.
hey, I think we should end. You have, I know, to go for the next one. So thank you very much for taking a short time, but at least covering everything. In case we have missed anything, we'll come back to you. But I'm pretty sure that this gives a beginning for everybody who wants to dwell in the private 5G as well as on the MCO and the openness. Some of the projects which you have mentioned in the context of use in India, and look forward to again working with you whenever best we can get it. But thanks for this is the last session, uh, session 1 of 15th day of the Pandit Madan Mohan Malviya National Mission on Teachers and Training. And thank you very much for providing your valuable time, and we look forward to working with you in future. Thank you very much. Have
Sure,
a great
Prakash. Thank you.